Okay, so number 25, negative 6k plus 6 is less than or equal to negative 48. We don't do well on this question as a state, so I'm going to work this one out over here. You see right here? I'm going to go ahead and just insert an extra page here at the bottom. Usually there's room here at the bottom, so you can kind of see the way I'm going to work this one out. I'm going to give myself room and just extra space to work this out. And let's see. I should have done this before I started the video, but oh well. Here we are. Come on, Cammy. All right, here we go. Negative 6k plus 6 less than, I think it's negative 54 or 48. Let me see. I actually don't know the number. I have zero memory now. My memory's just completely gone. So like when things like that, numbers, I'm always going back and forth. Notice I went back because I forgot it was negative 48. And so now I know. Okay, so let me show how we usually teach this. We usually teach this, right? And then we go negative 6k, and we tell our kids this is what you do. Here the kids do this. I'm going to show you every mistake the kid makes, right? They do this, and then you notice I forgot the negative, and then they tell me the answer is less than 10 because they can't do the division. We don't do well in this problem. So it's like, oh my Lord. And you know, they kind of know what to do, but they're still learning. They're still struggling to figure it out. They're seventh graders. And if you're a seventh grader watching this, I know you're gonna make errors. As a matter of fact, if I look at the problem itself here, last year, 64% of our students didn't get any points on this problem. So we got to start thinking differently. If you're a teacher watching this, we got to do things different, man. They're not getting it. Our kids just aren't getting it. So maybe start using algebra tiles, you know, and try to see it. It doesn't hurt. We're already doing bad, and it's not gonna get any worse, right? So let's see if we can do better. So I'm actually gonna model this with tiles. This representation right here, shaded in, is a negative x. Okay, so I'm gonna draw how many of these guys? I'm gonna draw 6 of them, right? So you can kind of see where the tiles come in and how useful they are. So I'll do my little line right here. And this negative 48, I'm going to draw a little longer. And I'm going to say that this symbol right here, the long one, is negative 10. All right, negative 10. Well, how many of these do I draw? 4. And I'm doing this so you can kind of see where I'm going with this and how easy this becomes with the tiles. Now I'm only using the tile representation actually I'm doing a little bit of teaching here as a teaching tool. All right, and the way I preach this is, I don't want the 6 on this side, so I will do negative 6 over here. And if you're going to say, well, there's that minus 6 we do to both sides. Yes, so this will cancel, and I'll put that negative 6 over here. Now, one of the things that happens with the tiles when I use the tiles is that I tell my students I don't want that negative 6. Okay, so usually we should have this situation right now, right? And then divide by negative 6, divide by negative 6, and the kids will get that positive. This becomes a positive, and this flips over. But not all our kids know that, and they're not good at this yet. So when I use the tiles, I tell them I don't want negative x, so these become positive x, right? And so we literally flipped the tiles over. If I actually have actual tiles, we flip them. If we're using polypad, I negate it and it becomes the opposite. But if I flip this side, I have to flip the inequality, and I have to flip these guys. These guys will now become positive. So as I'm going from here to here, you're gonna see it flip. And all I'm gonna do is I'm gonna evenly distribute. I'm gonna separate negative 54, actually now it's positive 54, into 6 equal parts. So I'm gonna go, for example, 1, 2, 3, 4, 5, 6. Oh, Jesus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so positive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These guys got divided evenly, but here they're negative, but here they became what? Positive, because we did what to these guys? We flipped them. And now I'm going to get 42 into 6 equal parts. Should be 7. Get it? Watch what I'm going to do. I'm going to grab from here. I'm going to flip it. 2, 3, 4, 5, 6, 7, 8, 9, 10. So these guys got flipped over here. Another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Another 10. Another 10 here. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. move these guys over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then these two guys, 1, 2, they flipped over. So now I got x is greater than one set of these. 1, 2, 3, 4, 5, 6, 7, 8, 9 is greater than 9. Positive 9. That's just me using the tiles. I did a pictorial representation of the tiles so I can get a correct answer in the state test. They can do this. If we teach it with the tiles, the student has a shot at this problem. All right, so now they know the answer is x is greater than 9. The other hard part is it solid? Is it a solution or open? It's gonna be open. And so if it lets me, let's see if it lets me drag this guy here. And I just move this guy over there. And there's my answer. X is greater than 9. We have a shot at this problem. And I honestly think with the tiles, guys, we can make a dent in the correct, in the amount of points we can earn, the amount of correct answers we get if it's multiple choice, and so on. We have a shot at this problem. And it doesn't just help my kids out for getting these kind of questions right. The implications of using tiles goes further down the line for them. They'll do better in TSI and so on, because these kids will be in high school. And we need them to be able to do the math without calculators in high school as well. That's to take that TSI, guys. There's really no calculator use on that one. So please use the tiles, or consider using the tiles if you want to, and go train you. If you're a student watching this, ask your teacher to teach you the tiles. All right, thank you.